One of the fundamental ideas of cosmology is that everything looks the same in all directions if you look over large enough distances. A new study using data from NASA's Chandra X-ray Observatory and ESA's XMM-Newton is challenging that basic notion. Astronomers using X-ray data from these orbiting observatories studied hundreds of galaxy clusters, the largest structures in the universe held together by gravity, and how the properties they display differ across the sky. The result challenges one underpinning of cosmology, that the universe is isotropic, meaning it is the same in all directions. Astronomers generally agree that after the Big Bang, the cosmos has continuously expanded like a baking loaf of raisin bread. As the bread bakes, the raisins, which represent cosmic objects like galaxies and galaxy clusters, all move away from one another, as the entire loaf, representing space, expands. With an even mix, the expansion should be uniform in all directions, as it should be with an isotropic universe. But these new results may not fit that picture. This latest test uses a powerful, novel, and independent technique that capitalizes on the relationship between the temperature of the hot gas pervading a galaxy cluster and the amount of X-rays it produces, known as the cluster's X-ray luminosity. The higher the temperature of the gas in a cluster, the higher the X-ray luminosity. Once scientists can measure the temperature of the cluster gas, they are able to estimate the X-ray luminosity. This method is independent of cosmological quantities, including the expansion speed of the universe. After doing this, the scientists then calculated luminosities using a different method that does depend on cosmological quantities, including the universe's expansion speed. The results gave the researchers apparent expansion speeds across the whole sky, revealing that the universe appears to be moving away from us faster in some directions than others. The outcome of this study has two potential cosmological explanations, either of which would have significant consequences. The first involves galaxy clusters moving together through space in a way not fully understood before. In the second, the universe is not isotropic, perhaps because dark energy is stronger in some parts of the universe than others. While other tests are needed to determine exactly what this study revealed, astronomers will continue to ask, and try to answer, some of the biggest questions in and about the universe.